All right, guys, so what we're doing today is continuing on with solving logs. Now, we did similar ones to these here yesterday, but instead of subtraction, they were addition. Because the ones that we did yesterday dealt with addition. The ones that we hear today, all three of them, we have two logarithms, but they are being subtracted. Now, our property of logarithms with addition, two logs being added together, log base b of m plus log base b of n, is equal to log base b of m times n, because they multiply. Yes, whenever we have two logs with the same base being subtracted, it is the same as them being divided. So what that means for us here is really that we have log of 3x minus 2 over 2 is equal to 3. And the log with the subtraction sign in front of it always goes on bottom. Whatever's inside of it goes on bottom, the bottom part of the fraction. So we have this here. Now we just need to solve for the value of x. So what can we do next? We can put both sides to the base of 10, because 10 to the log of 3x, the quantity 3x minus 2 divided by 2 is equal to 10 to the third. Well, 10 and the log will simplify out, leaving us with 3x minus 2 over 2 is 10 to the third, which is 1,000. Yep. That's how many zeros it has. Yeah, because, yeah, since we're dividing by 2, exactly, we would need to get rid of the division of 2 by multiplying by 2. You knew what you were to do, but it didn't come out. Cancel, yes. Which would give us our 3x minus 2 is equal to 2,000. Yeah, and then we would add 2. Yes, when we were dealing with plus the 2.
Well, you confused me when you said divide. I was like, wait a second, Eric. I thought you were confused. So I was confused.
This stinks. 6.
667.33.
Yes.
Before we times the 2, couldn't we have just wouldn't the negative 2 and 2 like canceled?
Because the 3x minus 2, those are stuck together with that subtraction. Now, we could have split it up and simplified, but to do that, what we would end up having, erase this, I would have to rewrite it as this, which this here would simplify to, and then we could add 1 to both sides, which would give us 3x over 2 is equal to 1,000 and
And still we would
So it is possible to do it that way, but it's a little bit easier just to multiply by 2 and then add it. Any questions on this here? So again, when we look at this here, because of our subtraction, we can rewrite them together. So we'd have log base 4 of x over x minus 1 is equal to 1/2. And then what would we do next? Is we want these to cancel out. Is equal to. Well, actually, yes, because 4 to the 1/2 would be 2, because the 1/2 is the same as the square root. So we're really saying the square root of 4, which is 2. Now, what can we do next? Right? We need to get rid of the division.
Oh,
No, we're on the same path. By. Right? Because we need to multiply both sides by our x minus 1 to get rid of that division. The x minus 1 and x minus 1 would, which would give us x is equal to 2x minus 2, yes. So we can add 2 to both sides, which would give us x plus 2 is equal to 2x. So x is equal to 2. And that's it. And we can plug it back in and check, and it does work out that both of these do work. They give us the answers that we are looking for. Any questions on any of these here? Because even if we plugged it back in, log base 4 of 2 minus log base 4 of, well, 2 minus 1 is 1, is equal to 1/2. Well, log base 4 of 1 and log base 4 of 2, we do have two positive numbers inside our radicals. And we would simplify this here, and log base 4 of 2 is 1/2. And it works out. Because again, anything where we have 1 inside the logarithm, it's always 0. So it works. The other one would work, but it's a little bit uglier numbers. All right, last one we're actually looking at. Yes, we put both sides. And these would cancel, leaving us with 8x over 1 minus x is equal to 'Cause these would cancel, giving us 8x is equal to 10 minus 10x. Yes. Which would tell us that 18x is equal to So we divide both sides by 18. You can get x is equal to 10 over 18. And that's it. Any questions on any of this here? All right.